Okay, let's check the audio on YouTube. So obviously, let me get a link. You count
One, two, three. Uh,
3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Oh, it's not
lollipop,
picking up my
lollipop,
audio.
hula,
Okay.
lollipop, lollipop, hula. By the way, you should add just an idea, like forum channels. Are you there? Uh-oh. And if you're lonely, sorry. Yeah.
Yeah, no, no, no. Oh, I'm hitting you twice. So the problem might be with StreamYard. I think the problem is StreamYard. Okay, let's remember to cut off the first 3 minutes. So let me just make a note in the YouTube. Cut off the first 3 minutes or so. Okay. All right. All right. Yeah, much better, much better. The audio is perfect. Okay. So what do you want to talk about? Do you want to resolve the problem that we faced? Want to
Uh-huh.
continue? All right.
Yeah.
Okay. So let me share the whiteboard. Let's see the problem. We need to make a one. I want to make short videos, like shorts that could go viral, like why space time is incorrect. You should say space or space fabric.
Hmm.
And the like everything. So notice I made so many breakthroughs in the last couple of days. Do you know why? Do you know
Why?
why this is? I think you're not gonna believe
What's your theory?
because what?
What's your theory?
My theory is because of mandible.
What?
Yeah, because of mandible, I completely changed my notion of what's proper scientific theory is. That it has to be understandable. It's I think it has to do with that. It has to do with a bunch of things, but it accelerated how I analyze problems in the world. I think.
What?
I don't know. I think.
Really?
I don't know.
Um,
I don't know. You have to explain. You have to account for it. You have to explain. why I'm suddenly so fruitful with my theories. It's like it's almost scary that I'm almost thinking people were accusing me of being like a conspiracy theorist on Reddit. Let me show you. Let me show you. No, I'm not gonna show you Reddit. You can just go to our. Let me see if I can find because I've been banned on our.
Why?
They said. Let me see. They said. You've made too many nonsensical and patently. Is that it? No, I don't think so. Where is the message? Oh, there is the message. Okay. So they're saying, hello, you have been permanently banned. Let me. Maybe I'll copy. Maybe I'll take a snapshot. 1 second. This is our Reddit. Let's go to general. I'll show you in general because I don't want to touch the screen because it keeps moving and it's impossible to move it back properly. Anyway, so right, so r slash ask physics on user slash Mr. Slave 41 is permanently banned from r ask physics.
Wow.
So, wait, by the way, you're tapping your mic, so I can hear it like really loudly. So, subreddit message via sent an hour ago. Okay, hello. You have been permanently banned from participating in our Ask Physics because your post violates this community's rules. You won't be able to post or comment, but you can still view and subscribe to it. If you have a question regarding your ban, you can contact the moderator team. The moderator team should be moderation team by replying to this message reminder from the Reddit staff. If you use another blah blah blah. Anyway, so I responded, I did not make a single claim in contradiction to the scientific consensus. I'm making zero claims against the scientific consensus. I'm actually going with the scientific consensus. I'm saying the scientific consensus doesn't go enough with the scientific consensus. The science today is not loyal enough to the scientific consensus, namely to general relativity. Namely, they're not employing general relativity in quantum mechanics. There's like they decided that it's two different worlds and they're not going to mix them. The subatomic world of quantum mechanics, they're not going to talk about general relativity in that world. Why? Because I don't know why. So it's not like I'm saying something against the consensus. I'm not saying anything against the consensus. They're going against the consensus. I'm going with the consensus.
I mean, yeah, like it's very. I don't know. I guess I don't know how to explain it, but it's not good. Very tribalistic, I guess.
Yeah,
That
of
they have to
course.
stick
Of
stick
course.
stick to a certain model of the world, and if you say something different, then that's a massive problem.
Of course. Like I
Yeah.
was thinking, will they give me a Nobel for this? And the answer is of course not, because I'm not in the club. Like, but
What do you mean?
there is a club. You see that it's a cult. It's a club. Wait, you're making
Hmm.
so much noise with your mic. What's going on? What are you?
Am I?
Yeah, like almost hurting my ears at this point. I mean, not all the time. Just once in a while, you're doing something with the mic. I don't know. I wanted to show you. I don't want to do that. Let's stick to the science. But I'll tell you, it was a very fruitful day because I was debating people in text about my theory, and they made me clarify this theory and clarify and clean it and cleanse it and purify and perfect my theory to such a degree that I actually understand it much better now. And
No.
it converges more and more and more with the scientific consensus. So very
In what way did it is it more similar to the scientific consensus now?
so I actually wrote notes in general, so we can I think in general or in the thing in YouTube in new YouTube videos. I actually made notes. Let me see. I think I just recorded the. Oh my God, I'm falling asleep. All right. So here, are you watching? You can watch my stream. Did I give you my stream? No, I didn't give you my stream. Let me give you my stream.
I am on the stream now, bro,
But
on YouTube.
let me place the stream so everyone has it in the new YouTube. We should get used to putting the stream always in new YouTube videos. One second, I have a message because I've been bombarded with Reddit the whole day. Reddit physics and Reddit futurism and technology. There's another.
That will do it.
Yeah, it was good. It was good. It was really good. You've made. Oh, wait, what? You've made far too many nonsense. That's one of the users, but I don't think he's a mod. I'll show you. It's really fascinating. And I used to hate before today. If you asked me yesterday, I would have told you I hate quantum mechanics. Today, I love quantum mechanics. I completely appreciate the whole thing. So much so, even the name quantum mechanics, notice it has the word mechanics, which is the word that shows up in Proposition 90, that a proper scientific theory has to be mechanical. And quantum mechanics, I used to always complain it's not mechanical, but now I've made it mechanical. I am so and now I'm fine with quantum mechanics. Now I can start studying quantum mechanics now. Until now, it was a complete mess. It was completely unscientific. But now it's scientific because now I have a mechanical explanation of at least one experiment that made no sense. And it's GR. GR is general relativity. It's literally the gravity model. Einstein's model for gravity, Einstein's theory of gravity. Now I am embedding it inside quantum mechanics. This is the holy grail. They call this quantum gravity. I've actually accomplished quantum gravity. We need to change the title. It's quantum gravity. We actually
Quantum
accom-
gravity.
Yeah, we have quantum gravity. We honest to goodness have quantum gravity. So we finally have quantum gravity. This is Nobel Prize stuff. I mean, I'm sure, I'm not sure. Probably I'm not gonna get it. They're gonna make fun of me and stuff. But this is definitely this is it. This is what everybody has been talking about the whole time. We finally have quantum gravity, the double slit experiment. I'm going to remove the word the double slit experiment, particle wave duality, and general relativity. So I'm going to just put demarcations between these. And that is the Holy Grail. I could show you so many people that say the Holy Grail. So I'm just going to say quantum gravity, double slit experiment, particle wave duality, general relativity. This is literally what everybody has been all about. Physics has just been talking about that. This is incredible. This is such an exciting day, all in one day. This has been such a productive day. Unbelievable. Just ridiculous. Just ridiculously productive. It's like Einstein had one productive year. It's called 1905, the miracle year, that he wrote three papers. The electro the so whatever the photoelectric effect from which we have solar cells, special relativity from which we have E equals mc squared, and the Brownian motion that he explained. Actually, he discovered molecules. You're not gonna believe it.
You just interesting.
In 1 year, he discovered that there's molecules or atoms. Until then, people didn't know, and he proved it. Then he discovered quantum mechanics by explaining the photoelectric effect, and he created the field of quantum mechanics that he hated after that. He hated that field just as much as I hated quantum mechanics until this morning. I used to always say,
Um,
what?
do you like uh? So like, were you like studying quantum mechanics before, or
Not really.
is it?
Not really. I cannot say that I did. I haven't studied quantum mechanics seriously yet. I can explain it at this point better than anyone else on the planet conceptually, but there's all these phenomenon that people have been working on, and it's like I just put together the pieces of the puzzle, but there's experts who know the pieces of the puzzle much better than me, but they don't know how to put them together. I'm able to put them together, but I'm still not too familiar with each piece of the puzzle. But I my intuition is that I've been able to put the puzzle together because at least I knew that there is an issue. So I felt the paradox. I couldn't function for all these years since I heard about the double slit experiment and particle wave duality. I couldn't. I could sleep, but this kept bothering me, and I kept hearing explanations and listening to lectures, and and nothing settled my mind. Nothing put my mind at rest, at ease, until this morning. Nothing settled, nothing comforted me. Nothing explained particle wave duality, double slit, and actually there's a lot of issues with special relativity and general relativity that I never figured out that also today work better. But I've been since we've been working together on general relativity and special, like in I don't know, a couple of days ago I started working on special relativity. I don't know why, and then I don't know why I moved into general relativity somehow, and then into quantum mechanics, and it just the puzzle pieces just fit together perfectly. Anyway, look, you're going to understand. You can ask as many questions as you want because I want you to understand the question, the problem, the paradox, the double slit experiment, and the particle wave duality. I want you to see it and feel it and be as perplexed about it as I and everyone, the whole planet is. And then you'll try and introduce my solution, and either you'll see my solution as resolving the paradox, or you're going to tell me that I'm wrong. But everybody on Reddit, they kept attacking my solution, and they couldn't, like, I had rebuttals for everything. Everything is accounted for. It's actually them who are not accounting for the consensus. They're ignoring the consensus, and they're blaming me for I don't know for what. I kept telling them, towards the end when I started to figure out the exact debate dialogue tree. So I told them, you're not disagreeing with me. I'm not. They kept saying, your theory has no math. So at the beginning, I was like, yeah, you're right. It's a problem. But towards the end, I was like, of course, there's no math because I'm just using general relativity. And we have the math for general relativity. Actually, here it is right here, right? If I'm going to scroll up, and I think it's here. That's almost. And there it is. This is general relativity. It's really straightforward. And Can Dairy explained it to me. I knew I had intuition, but this is like a very good mathematical tool. So once he explained how to derive this, it was so straightforward. I still don't really understand this, and this is fine. I think there is an issue here. The C has to show up. The C show up here. C doesn't show up here. And C doesn't show up here. I think if you put C here, you'll see the issue. He said the issue is that RS over R at R equals, if these are both equal, then it's 1 minus 1, then you divide by 0. That's the issue. So it shows up here and it shows up here. So I don't care. I told them I don't care about the math because I know the intuition from which this equation is derived. So I can just go directly to the black hole. The RS equals R is where it's called an event horizon. We'll come back to it. We haven't discussed black holes. We still need to finish black holes. Look, let's continue. You'll be the judge for yourself. Just you'll be the judge,
Okay.
and that's it. All right. So
Mhm.
we were at some point. What was the point? So we were discussing it. Yeah. So we said that there is such an experiment. Now, before we continue, let me just make sure, right? Because I've seen people talk about it. Now, this experiment you cannot find on YouTube. And actually, this experiment you cannot find on YouTube. And I have scoured YouTube all these years. And at one point, I started complaining. They only show animations of these experiments. They never show. Today we're gonna reproduce the double slit experiment. There's no such video on YouTube. Can you believe it?
I believe you.
So let's prove it. No, I mean, not let's not prove it. Let me share with you my screen because I do want to look at least look for the double slit experiment. I think this should be fine. Yeah, it looks good.
Let me click your
No, no, no. Yeah, I'm gonna first click that and then click this. Good. So it works. It's good. All right. So let's look for the the double slit experiment reproduced. So this is double slit experiment. See the list here is experiment, explained, observation, animation for dummies. Morgan Freeman
uh
performed with electrons. Let's click this. Right, this seems the best one. Let me see. Okay, so this is from 8 years ago, a minute and a half. Let's allow the audio. I'm not hearing any audio. Yeah, and it's moving. I'm not hearing anything. Is there any audio? What's going on? Performed with electrons. Oh, there's no audio. Okay, good. Yeah, that. And they're not showing the actual experiment. They're just showing the results. What it looks like on the board. Well, if we believe them, so he says here, this shows the electron build a pattern. Um, build a pattern one electron at a time. They fired one electron because with electrons you can easily fire them easily. I don't know how easily it is, but you can fire them one electron at a time. Because in order to fire an electron, I think you basically have to heat up the cathode, the negative thing. I think the cathode is the negative, the anode is the positive. So you just we'll talk about how to reproduce it. So, but he's just showing the result. He's not showing the apparatus. Okay, double slit experiment, wave particle duality, explain. But he doesn't show it. It's just explained. How long is it? 7 minutes. It's just explained. That it's not shown. Sh- Okay, so she's showing, but she's not showing one particle at a time. She's just showing the double slit experiment, the original double slit experiment with normal light, that they just proved that light must be a wave. But she's not trying to prove light is a particle, right? That's what she's showing. That's what she's showing. By the way, she's a hot chick. I mean, she's definitely hot.
Oh,
She's beautiful, beautiful Indian.
let me let me Indian. Oh,
Well, yeah, yeah, she's gorgeous. Absolutely, and she's a PhD, really smart, really nice English. She's your neighbor. You should bang her.
uh-huh.
Yeah. Anyway, she's not reproducing it. One electron. But where is the apparatus? Show me the apparatus. He's not showing the apparatus.
There's a cool animation I saw of the double
No, no, this is not an animation.
slit experiment.
Wait, what?
There's one I saw before with an animation which was pretty simple.
But I don't care for an animation. An animation is an explanation. We first need to see the experiment reproduced. Science is about reproducing experiments. One of the rules of science is you need to be able to reproduce an experiment. You cannot trust what the data that someone shows you. You need to reproduce the experiment from scratch, from first principles, with no help from anyone, because you're going to be biased. You need to reproduce the experiment. And the fact that not a single person rebuilt an apparatus to reproduce the experiment is terrible. It's absolutely shameful. Okay, let's see. One of the experiment. So it's fine, but he's not showing the apparatus. He's not showing the actual lab. Right. You see the lines. You see
Hmm.
the lines, which is good. I mean, this is good. And they're using electrons, and electrons are not waves. I mean, whatever you want to say about electrons, they're not waves. They never behave like. I've never seen an electron behave like a wave. An electron beam doesn't behave like a wave. The lightning doesn't behave like a wave. A spark doesn't behave like a wave. These are not waves. These are particles.
The
It's
the
actually
lines
what
the lines which the waves make are like lines in a cornfield.
in a cornfield, but that's not what we're trying to prove. We're trying to prove that these are the same as the lines in the water, like in the interference pattern of the water waves.
Yeah, it's like a just an analogy.
Okay, but the proper analogy, if I mean the purpose of this experiment is to show that you're getting these lines just like as if this was water. This is what water waves or sound waves or light waves would look like if you assume light is a wave, which it is, and we're going to discuss it. But anyway, but they're firing one electron at a time. Electrons are definitely particles, and you can fire them one at a time if you just manage to right because you have an apparatus. You know what the word apparatus means, by the way? It just means your
Yeah, it's like
it just means your
sorry, go ahead.
laboratory setup. It just
Mm,
means the equipment for the experiment.
mm,
Like the stuff that you need for the operation. Anyway,
yeah,
so but here we're assuming that he's not fabricating the data. So that's not good. Let's look at this. Quantum mechanics double slit experiment, is anything real? Right? But is anything happening? That's nonsense. That's not to claim that only one photon at a time. You can't see photons, and we're trying to prove if light is a particle or a wave. Up until now, we're assuming it's a wave. We know it's definitely a wave. Now we're trying to prove it's also a light. It's also a particle. You cannot use photons. You cannot use light for this experiment. I'm sorry. That's absolutely a terrible experiment. You need to use particles. The best thing is electrons. Electrons are just a little bit more complicated than using light. Light is more simple. A laser is more simple, but I don't know what you mean by a photon. You can't see a photon. Electron is. I can see the electrons. I mean, I can show you experiments where you see electrons. Let me actually show you an electron beam because you've never seen that. An electron beam. An electron. You actually, but you know that that electrons. You see, so let me explain. Are you following what he's explaining?
yeah. I need to see videos like at least twice to like
Yeah,
understand it, bro.
and this video, I mean, he's barely showing the details. The point is that you can see in this picture right now. I don't want to touch it because if I touch it, I don't have a choice. Let's go to this video. So I actually, where let's stop him. So I want to show the thumbnail picture. This is basically the thumbnail picture. So this is an electron beam. The purpose of the paper or whatever is just so that we see it more clearly, because it's actually
Okay.
difficult to see. But he's using a magnet, so electrons are negatively charged. So if you use a magnet, I don't know if this is positive or negative. I think this is a magnet. So it actually, yeah, I think it's a magnet. So electrons actually are deflected by a magnet. It happens for, I mean, Einstein explains why it happens, but this is how electrons behave. But if this was a wave, it wouldn't make any sense. Why would a wave be deflected by a magnet? But if anyway, so there's other experiments that you can actually see the electrons. Let me find another experiment. One second. Let me shut him up. I don't want him to make noise. Shut up. Okay. So shooting an electron beam through air. Through air, you could do that. I didn't know you can do that. Because in air, it basically reacts and becomes a spark. I'll ignore that. Let me see. I think I saw this experiment. One second. Okay, here's the beam. But that's not so good. I'm looking for. There's a certain experiment where they fire an electron beam at a metallic propeller, and the propeller starts spinning because it's being bombarded by actual particles. But there's no way we're gonna find it. Anyway, it's a good idea to go through as many videos as you can. This is incredible. This is the original oil drop experiment that they discovered the electron or the mass of the electron or the charge of the electron and the mass of the I don't remember. Just unbelievable stuff. Okay, and here is this is called a cathode ray tube. That's basically an old television, and the green is an electron beam. Anyway, electrons it's as guaranteed as can be are particles. So they fired a beam of electrons. Let's get back to our. Is this it? Oh, that's it. Sorry. This. Okay, so let's get back to our drawing. So we have this experiment. Can you?
Are you on the whiteboard now?
Yeah, but you can. I think the best thing is if you watch me in the stream.
It's just there's a lag. So
There's a lag to the stream. I need,
I
oh, one
believe
second.
so.
We have a bunch of messages. Cygnus says yo-yos. Wait, is he with us? Oh, yeah, he's with us, but he's not listening to us. So he has a bunch of comments. Actually, fields are the best current understanding, not a tiny ball. What we have here, flat earthers, FFS. They're all been reproduced.
For beep's sake.
For oh, okay, beep saying okay. They've all been reproduced. Science isn't a YouTube video, bro. Okay. I'm just saying that I didn't see a single experiment where they showed the apparatus. That's all I'm saying. I mean, they're showing the results, they're just not showing the apparatus. Can you explain to me this setup, what we're seeing here, Mr. Judas, Gnostic Judas?
There's a positive and negative pole. The spark is traveling through the two slits, double slits.
Mm-hmm.
Uh, it seems like it seems how do I? And that's all I can say. That's the spark is traveling through the slits.
So, what was the result? What's the expected and what's the result?
Uh,
What did they expect to see, or what would you naturally expect to see? And what do they claim that they actually saw?
mm, Maybe look. Well, it's either going to be a wave or it's going to be a particle.
I mean, they're sending a beam. You saw the beams. You saw the green and
Hmm.
the blue beams and the
Yeah.
yellow beams of electrons. You saw them. So what do you expect to see if you fire a beam? What do you expect to see on the display?
Well, when they come through both of the slits, it's going to divide into two. It's
Right.
not going to act like a wave.
What
It's
if there what if there isn't two slits? There's no barrier at the center. What would you expect to see?
But is there any hole?
There's no barrier. If I completely remove the barrier with the slits from the center, completely remove it, what would you expect to see on the display at the right?
Well, if there's no like hole for it to come through, it's just going to bounce off and come back.
No, there's no barrier. No, there's no barrier. You're saying, is there a
What
hole?
do
I'm
you
saying
mean?
there is an infinite hole. Like you're saying, is the door open? I'm saying there is no door, there's no wall. Like let's say you say, I tell you, okay, come to my house, and you tell me, but is the door open? I tell you, well, there is no door and there are no walls. I live on a field. There's no walls. There's no door.
Oh, it's just going to travel in a straight line then, because it's
Exactly.
not going to be impeded by anything. Yeah.
Exactly. Okay, and then let's put a board in the center with a tiny single slit in it. What would you then expect to see on the display at the right?
If it's one slit, it's going to go through the slit, and but that's how it's going to act. It's just going to go through
What will we see on the display?
a straight line, which represents the beam.
Wait, so the beam is like it's very similar to a laser beam. I mean, this is a the point from which we're firing everything is a single point. So what comes out is a single beam. So what would you? It's a
Hmm.
single beam that hits the display. We're looking at it from the side. If I'll draw it like in 3D, let's draw it in 3D. So it would be here is the gun. This fires electrons. So it fires electrons, and here is the. Let's put. Oops. Let's make this bigger. How big can we make it? All right. So let's say that we make a hole here, and so the beam goes, and the beam continues to travel, and there is a display at the back. Let's make it a little bit smaller. So, what would you expect to see on the display?
So there's like a circle, and then there's like a dot in the
Yeah,
middle. Is the
yeah,
dot
yeah.
is the dot in the middle supposed to be the slit, and the bigger circle is supposed to be the beam?
What? Wait, this gun fires off electrons. The electrons go through the slit,
Hmm.
and then they hit the backboard. We call this
Yeah.
the detector or whatever, and
Uh-huh.
you're going to see a bunch of dots here over time. It's going to if this is fluorescent and it reacts with
Oh, right.
electrons,
Okay. I see. I see. Yeah, I see what you mean. I see.
it's just going to be a
Yeah.
bunch
It
of
was just. Yeah. Okay.
bunch of
Okay.
dots. That's it. That's it. All right. Now let's reproduce this experiment, but this time let's make it with two slits.
Hmm.
So we're gonna make not a single slit, but two slits. I don't know. Oh yeah, we can pick this and move this. Oh, we can't. I delete it. No, you know what? Yeah, okay. Let's. delete this, delete this, delete this. So this time we're gonna put either two holes or two slits. It doesn't really matter. Let's put, since we started with one hole, we'll put a hole here and a hole here. But they have to be close enough so that the beam has to be wider than these two holes. So these two slits need to be, I need to make them thinner. So let me show you. So we need to make them like the beam. Let's say the beam makes a hole. So this is a straight line, makes a hole here. This is where the beam makes a hole. So we need to make it's that's as thin as possible. So we're gonna make one hole here, and the other one is gonna be right next to it. It's but there is. Let me move one to the left, and that's it. So the beam that comes through, it's, let's use red maybe. So it sometimes goes through here, sometimes goes through here. It goes right in the middle. The beam is wide.
Mhm.
It's not as thin as I drew it. It has to go through both slits simultaneously. Okay. So what do we expect to see at the back? And what do we end up seeing? What do we expect to see and what do we end up seeing? What do you
Well,
think?
you expect? Can I draw or?
Yeah, you can draw. But I don't think I'll be able to undo what you do. So I'll make a copy for you so that I can then continue with mine. Okay, you can work on the center one. The center,
On this one.
the center.
Okay.
Yeah. No, no. Yeah, yeah. And
So
you can make it bigger. You can maximize it so you can see more details if you want. What do you think we're gonna end up seeing?
this is what you expect to see. So one, this is one. This is it coming out of the left hand slit, and this is it coming out of the right hand slit.
Very good. Excellent. Fantastic. Now let me make another copy. One second. I'll make another copy. I'll put it here. And this copy I'll give you. So what is the actual result? Show me in this one what is the actual result.
Which one are you giving me? Sorry.
The third one. This one. You can't see which one I'm
Okay.
pointing? This one.
Yeah, yeah, I can, I can, I can.
So what is the actual result, do you think?
I think they're going to smash into each other, all the particles,
What's gonna show up
like
on
collide.
but what's gonna show up on the fluorescent backboard, the fluorescent board, on the fluorescent plate? What are we gonna see?
Uh, Something like this.
It's a little bit different. Let me show you what we end up seeing. So what we end up seeing, wait, I'll show you on mine. So let me give you mine. So we have all copies. So what we end up seeing, what we end up seeing is something really surprising. We end up seeing, I wouldn't say there is, where at the center where the dot used to be, we actually don't see anything. There's nothing. Oops. Instead, what I was going to do is remove all these dots. So we don't see any of these dots. Where these dots used to be, there's now nothing. Instead, to its right, let's do in the red, we get a bunch of dots to the right, and a bunch of dots to the left. And then nothing and a bunch of dots. Nothing and a bunch of dots. Nothing and a bunch of dots. Nothing and a bunch of dots.
Oh, okay. Wow. Okay. Interesting.
How do you explain this? What's your so this and this no one could explain this. Why would something that is obviously a particle disperse in something that I mean, what does this remind you of? What does this pattern remind you of? What is this a pattern of?
It looks like a wave.
Exactly. This is the result of the wave interference. So that if you would say that these particles going through it's actually a wave and there's a wave going through these two slits, so it splits into a wave from here and a wave from here, and the waves are interfering with each other, then yeah, that's exactly what you would get. But electrons are not waves. And we're firing each one electron at a time. Electrons are kind of big. I mean, we see when you see a spark, those are tiny electrons, but yeah, it's not that many. You see them; they're they're super tiny, but they're shiny. You can see them. So what's going on? How could this be?
Um,
So this is the double. Yeah,
maybe light is just not a particle, and it's instead just a wave.
this is electrons. This has nothing to do with light.
Maybe the electrons are just waves then instead of particles,
How you see? But when you see
or they are acting like a wave. So
how are
this
they
is what
acting like a wave?
this is what you would expect a wave to do.
Yeah, but you see them. It's a beam. A beam is not a wave. A beam is like a beam, like a stream of water. You might as
If it
well. You might
looks
as
like a
well.
duck,
You might as.
quacks like a duck, and
Hold
talks
on.
like a duck, it's
Hold,
probably a duck.
hold on. You might as well use a water jet through two slits and get this wave pattern. Would you then say that a water jet is a wave?
If it produces what you would expect of a wave, then I don't see why not.
But what do you mean? What do you mean? I mean, it's
Like
obvious, but it's obviously particles. What do you mean? It's some of the time it behaves like a particle. When you look at the beam, it's a beam of particles. You right? They're going through one at a time. By the way, when they go through one at a time, you don't see them. They're too small. You actually don't see them going one at a time. You can see them as a stream of many, 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 many of them. But when you see them, I don't think that they ever. What would happen if they fire many electrons at once? That's an interesting question. It's like when they fire them all to one at a time, they don't see each one, and then they just distribute themselves in this weird pattern, and it's called a wave pattern distribution. But I don't think they ever fired like is a beam of electrons to produce this. I don't think this experiment has ever been done. Let's assume that they did it and they still get the wave pattern. But it's obviously a stream. It's obviously a stream of particles. It's not a wave. So what's going on? So what's your explanation?
well, if you've ruled what I said out, then
I didn't rule what you said out. I'm not ruling what you said out. You're saying exactly what all the physicists have been saying until today.
oh really, okay,
Yes. And Einstein hated it. Einstein
okay.
absolutely hated it. He said, "What do you mean? You can't just say that it behaves like a wave, therefore it's a wave, because it also behaves like a particle. You can't just say,
Maybe it's just problems with how we are seeing it.
but we're not seeing it. We're firing one at a time. We're not seeing it, and when we fire a multitude of them, they spread like this. Let's assume when you fire a multitude, they spread like this. When you fire one at a time, they spread like this. They always spread like this, and it's particles. Electrons never behave like a wave. Never. It's not like light that a stream of light. I mean, a stream of light. We don't know at this point. We don't know because we're never able to fire one photon at a time. Even though people say they can, it doesn't matter. When you fire, you know that electrons, you can see the beam. You can see the spark. You can see the lightning in the sky. You know that electrons, you put them in the battery. Electrons come from the battery. This is this is controlled by a battery. There is a battery here. I put a battery for this thing. We know exactly
I
what
was,
went.
I was, I was saying we're observers, and maybe it's not a deficient. Maybe it's not that the light is acting weird. It's just problems with how we are perceiving it and our observation.
What do you mean? This is not light. This is electrons. We're talking about a beam of electrons. It's very confusing.
Yeah,
I
same
used to be
difference.
just that you know. I used to be confused in the beginning. What's the difference between a beam of electrons and a beam of light? It
Hmm.
looks like a laser, but it's not a laser. A spark is not a laser. Laser is light.
Does it travel at the same speed? Or
No, no. A beam of electrons is very slow. It's extremely
oh,
slow.
okay, cool. Yeah, that's very useful actually. Power scaling. Oh,
Let
okay,
me show you.
interesting.
Let me show you how slow a beam of electrons is. Let me see. A beam of electrons, an electron beam. Let's see. Moving a propeller. Can we find it? You can curve it. So an electron beam reacts to magnets. A light beam does not react to anything. A light beam reacts to a lens. I don't think an electron beam reacts to a lens. It reacts only to magnets and to electric fields. Let me try and find an electron beam actually moving a propeller, like a real propeller. Um, the videos don't play normally. I don't think I can find it, but there is actually a video where they actually you can see the propeller. It's like a it's like an aluminum propeller, and you can see the beam of electrons just hitting it. Like when I first saw it, I said, "Oh my god, it's not light," because I see that you keep getting confused between light and electrons. I understand why
Mhm.
you would think they're the same, but they're completely different. They have nothing to do with each other. Almost. I mean, they have some relationship. All right. There's nothing. I'm not going to be able to find it. If you could find it, that'd be terrific. Anyway, so what do you think is causing this behavior? Okay, so scientifically, let's talk scientifically. So we witnessed a phenomenon. We witnessed a phenomenon. We have never been able to explain it. So this is ripe for an explanation. If you want, we can actually listen to people explaining this, and all they're going to say is we don't have an explanation.
Okay,
But
let's maybe.
what?
Yeah. We can hear some people explain.
Fantastic.
I don't know.
Fantastic.
Yeah.
So let's talk about the double slit. Explain. The double slit experiment explicada. Explicada. Okay,
Uh,
so this guy, I love this guy, Jim Al Khalili. He's your neighbor. Wait, let me lower the volume. It's so loud. There's no way to lower the volume from here. So terrible. So terribly terrible. Hold on. Can I control the volume from here? Yeah? Oh.
Yo, one sec, one sec, one sec.
What?
Please pause. No, it's just hard to change from the whiteboard to the video sometimes.
So just go to my stream. You'll see it in my stream.
I want to watch it on both. Okay, I've got it.
So okay. Oh my god. It's loading. Why is it so slow? Jesus. Let's give it a second. Oh my god. I can't believe it. My internet is not that bad. You want to tell me my internet
Yeah.
is that bad? It's not. I have like an expensive internet. What's going on? And the CPU is zero. It's like my computer is not doing anything.
Are you sharing the internet or it's a bit
No, I'm
annoying?
all alone. I'm not sharing the
Uh,
internets. It's only my internets.
oh,
Anyway, I'm already not liking his explanation. It's too slow. Even Dave explains might be better.
what do you mean? Even Dave explains
I don't like Dave explains, Professor Dave.
why? Why?
Because he's like an elitist. Oh my god, my internet
What?
is
What?
pooping.
Look at you. Can you expand on that?
You know, they're elites. They don't. He's not an original thinker. He's not like me. He doesn't take chances. He doesn't explain anything by himself. He only repeats what he hears. And he wouldn't move a millimeter off the scientific consensus because he knows that they'll chop off his head. You know how he knows how dangerous it is to actually express yourself. And he has nothing.
Oh,
And if somebody like me says something, he'll come after me. He's one of those that's going to come after people like me. Just
yeah.
he's like defending. He's a defender of of the scientific consensus. He's the defender because I'm the enemy of the consensus because I'm going to shake up the consensus. Uh,
The way you're framing it sounds like you think he goes after people. What do you mean?
they do. It's not him. It's them. It's the mob. It's the
Um,
establishment. He has 3.2 whatever million
pa-
viewers.
the
People
paparazzi.
people like me are basically his enemy because like I'm an outsider to the system. So I'm not supposed to be able to be so smart. I'm not supposed to be able to answer questions that Einstein couldn't answer. These guys, Planck, Einstein, Bohr, these were super geniuses to him. And as far as I'm concerned, to me too. So he cannot allow like a bumbling buffoon like me to him I'm an idiot. I'm a warming denier, because I deny most of the scientific consensus. So to him, I'm pure evil. I'm Alex Jones. I'm Voldemort. You could bring together all the worst names from all of modern fiction. I'm everything combined. Even though Einstein was also a nobody when he wrote all his great papers. He was working as a patent clerk. He was a government employee. He was like a post office guy. He was like a nobody. And the one who realized he's great was Planck. I don't think anybody else realized Einstein was great. Planck read his paper, and Planck said to, I think, to Bohr was his helper or something. He said, "Go get him, bring him before me. I gotta talk to this dude." And then Bohr came to visit Einstein in the office and told him, "Let's go, pack your bags, we're going." And that's it. Until then, Einstein. I think after that, Einstein still went to work the next day as a nobody. It took a bunch of years. It took a while before Einstein actually got a job like a normal human, like a normal genius, like the super genius that he was. So they didn't know, like they didn't know who he was. The day before, he was a nobody. And Dave explains, Professor Dave would have said, "Oh, that nobody Einstein thinks he's smarter than Planck and Bohr combined," which he was apparently. Einstein was smarter than everybody else combined, apparently. Anyway, it's whatever. Look, it's not like it's not it's not like science is hard enough as it is. It's also that we have to deal with these guys that think, these white knights that think that
These
they're
quacks.
no. I'm not gonna say anything negative about him.
Ah,
I'm just gonna say he's gonna white knight. He's gonna be the defender of the consensus. Yeah, fine. Look. It's hopeless. This is why humanity is hopeless. So I'm just hoping to make a dent and to make somebody smile, and just to know that I'm going to cause somebody to smile because they're going to understand me and get some deeper realization about reality. Just me knowing that, that's good enough. If a day will come and they'll recognize me, even better. But their recognition, this guy recognized me. He's only going to recognize me if the consensus recognizes me, and to move the consensus is really difficult because you see,
no,
it,
doesn't that promote people to shape their different, like their competing views to make sure it's superior to the model that is the consensus?
what? I didn't understand what.
Okay, so if it's really hard to change the consensus, doesn't that challenge people to like to improve their ideas so that it can become the consensus and displace what was the consensus?
But you see, they banned me today. How is that going to make my work easier? What makes my work easier is the ability to debate people. But if you ban me, I can't debate. You're destroying my work. You're just erasing my work. They banned a whole day's worth of debates online. Was just, I think, pretty much deleted. Like I spent
Reddit isn't everything.
what?
Reddit isn't everything. Well, you should publish like a paper. At
Maybe.
least if it doesn't fall through, at least it's still there and it's set in stone. So that you can't say that you didn't do it. Like they can fall back on it and say, "Oh, but this guy discovered this 10 years ago."
It's whatever.
You
Look,
know.
I made a video. If anybody ever turns my video, or anyone ever discusses my discovery and claims it to himself and gets a prize, I'll just bring it up, and hopefully they'll give me the prize instead. I don't know. I don't know. Look, it's a club. There's nothing you can do about it. It's just a club, and you're not in it. You don't have 3.2 million followers, and you don't have a PhD. He doesn't have a PhD. He has a master's. I don't even know in what. Anyway, it doesn't matter. We're here to learn about the truth. If humanity doesn't appreciate our work, so be it. Einstein was appreciated as a draw of luck. It's just that Planck. I don't know how the paper ended up on Planck's table. Planck could have easily have missed Einstein's paper because no one took Einstein seriously. Because everyone thought, what Einstein didn't reference any papers. He didn't base his theory of relativity on anything. Like his papers had no reference. He's like me, no references. Everything from first principles. Enjoy the read. That's Einstein. No need for
No.
first principles here. I mean, no need for references here. It doesn't matter. Look, let's continue. I want to I want to record it. Everybody should hear it. If they reward us, fantastic. Don't reward us, it's also fantastic. Everything is fantastic either way. We'll enjoy. We're gonna enjoy. We'll enjoy the ride. This I'm doing this just for a good time. This is not my main source of income, so I'm fine. I'm fine either way. I'm happy either way. Everything's fine. Let us continue. All right. Let's hear
Yep.
what he says. And no internet. This is good. He's going through the history. So I don't remember when he said, like 18 something. Do you remember what year? 1801. This is 100 years before Einstein.
No.
Einstein published his work in 1905. So this is over 100 years before Einstein. So Young performed the experiment to prove whether light is a particle or a wave using the double slit experiment just with light. This is called the Young experiment. The original Young double slit experiment. You have questions?
No, not yet. No.
Okay. So what do we see here? So there's a source of light. It goes through two slits, and then the light comes out of both slits, and we get an interference pattern. And this is what we see. This is the front. They say here this is the front view. This is not the side view. This is the front view. So if the light was hitting from our direction, this is what you see actually sideways. It's confusing, but what you see is dark light, dark light, right? Which is just like
Mhm.
if water hit this screen, we would see something like this too.
But basically,
Mm,
just to
hmm
water it down, the light's coming through the two slits and acting like a wave.
Yeah, it's acting like a wave because we see a wave interference pattern. This is wave
Wave
interference,
formation, yeah.
right? This is how water waves behave. This is probably how sound wave behaves as well. For all we know, this is how all waves behave, and we can understand it. I mean, if you draw the actual waves, you can predict this angle of the straight line, and you can make predictions just from the wavelength. You can probably make a prediction about the distance between the high marks, the lighter marks. Let me see if I have any messages on my old iPhone. I don't know if it should work. I tried created them. Noticed. I don't know. Okay, doesn't matter. Reddit. This. Okay. All right. So far, so good.
Yep.
So, by the way, this entire field of just studying waves, any type of waves, is called wave mechanics. And you can do a deep dive just to study wave mechanics. It's a whole separate universe. And you can study Fourier transforms, I think, that is a very deep analysis of waves and adding waves and multiplying waves. It's a whole universe of the mathematics of and the physics of waves. And you can do multidimensional waves in using partial differential equations. And it's a whole huge universe, super duper universe. Okay, let's continue. Maybe one day the internet will work. Perhaps. So interference is when two waves interfere with each other and they make these like, so you have a let's take this wave and this wave. So this is, let's say, the high, this is the trough, and what do you call the low point? The trough is the high point, and I don't remember what you call the low point of a wave. So if the two high levels of a wave meet together, you get an extra high region. This is super high. Like basically two waves where they meet, they interfere positively. It's called interference either way. They interfere positively and you get like an extra lit area because the light from here and the light from here get added together. Whereas this is the high. He doesn't show the low. If we look at the low, then yeah, there's a way to also show that the two lows create a dip. If the two low, wherever the two lows meet, that's where you get the dip. So it should be about low. Right, this is low. This is low. Low and low. I don't see low meeting low. Low is, I guess, between two waves. This is the low. I don't know how to do it because here this is high and high, and I don't know what this is. This looks like high and low, so it's zero, but it's never going to add low and low. Like I want to add the white of this wave to the white of this wave. I think it's this area. So it's going to be this line because anyway, never mind. Let's continue. Right, so where two highs meet, it's called constructive interference, and you get the high watermark or light mark. And where two lows meet, you get a depression, the maximum depression. So it's destructive interference and productive interference. Are you like, do you have any idea what's going on, or are you completely lost?
All the words are going over my head, but I know I have an understanding of what's happening when the light goes through the slits and why the I forgot what the lines are called, but I understand why they form
They're just called bands. That's all. He called them bands. And
bands.
constructive
Mm.
interference is where two highs, where he doesn't show two highs here. He shows this is two highs. The high and the high meet, and you get this is the maximum lit band, the most lit band. And over here, I don't know how you can prove that it's low and low. Anyway, look, I don't know this completely either. I don't think anyone does. There's like, it's a whole thing to know. But the thing is, it reminds us of the way water behaves, and it's completely. If you assume light is a wave, because we don't see these waves, we don't see this interference. All we see is this. But this is the explanation. So we're able to explain using wave mechanics. We're able to explain what we see. This is the data. Only this is the data. This is the theory. This is the
Oh,
explanation for what's going on. We don't see this. This is our mechanical model to explain the data. This is the data. Do you understand the distinction?
yeah, yeah.
Great.
So what's on the right, the black, white, the lines, the bands, that's confirmed. That's the data,
Hmm.
and on the left, the waves. That's like the theory in order
Exactly.
to explain
Fan-
why the
Exactly.
confirmed stuff actually happens.
Exactly. Perfect. Perfect.
Okay.
Okay, continue. That was actually an interesting point. Nothing here is critical. I don't want to
Max
over.
Maxwell's demon.
Yeah. Oh, you know Maxwell's demon? That's so funny. Um, so what he said is that I think he said the distance between these guys is a function of the frequency of the light. Well, I don't know if that's correct. It's a function, I guess, of the wavelength, because basically from the data, imagine this, from the data, you should be able to figure out the wavelength, because the wavelength, this wavelength has to do with this distribution. So the distance between line 2 and line 0 and 1, I think it should first of all be equal to the distance between 1 and 2. And from here, you don't see it. I don't think you see it. But the thing is, 0 and 1, 1 and 2 should be the same distance. But this distance should be a function. From this, you should be able to figure out the wavelength. Yeah, I think you should be able to play around with these things and figure it out. I don't know how to do it. I mean, this is many, many moons ago already. This is already touching my theory because these are the waves, and as you can tell, let me ask you: is this a scientific theory? This is
Yeah.
Maxwell's classical electromagnetism to explain light. This is a model to explain light. Would you say this is a mechanic? This is uh, did you sneeze?
Yeah. Sorry. Done.
No, no, it's
Oh,
okay. It's okay. It's okay. You don't have to silence yourself. Anyway, would you say this is a
okay.
a proper scientific theory? Does this explain to you how light propagates through between from the sun to Earth? Does this
Well,
explain?
I don't understand how it's explaining how light comes using that theory.
Right. So yeah. So this is Maxwell's theory, and I think it's an unscientific theory. And my theory comes to replace Maxwell. My theory is designed to explain Maxwell's electromagnetic whatever. Because he came up with an explanation, but it's an unscientific. Because my definition of science, it had the theory, the model has to be mechanical, and this model is not mechanical. It's a drawing. There's no mechanics here. I cannot build a mechanical contraption to simulate this. I don't know what's going on here. I
You
don't know
can't replicate it.
what.
You can't replicate the experiment.
No, Maxwell didn't conduct. Maxwell was not an experimentalist. He never conducted any experiments. Maxwell just came up with the mathematics to describe
Oh,
electricity, magnetism, and their interaction called electromagnetism. Anyway, we're going to come back to this. We still need to figure out Maxwell, electromagnetism, see the problems with electromagnetism. From electromagnetism, we actually derive Einstein special relativity. We'll see the problems with special relativity. We'll see the problems with Maxwell's modeling, and and then will inject my model, and you'll tell me if my model fixes the problems that I'll point to you about all this. All right, let's continue. It's going to take a while to load. Only God knows why it takes so much time to load. Right, but he's not showing the experiment. He's going through all the history, but all we want is the double slit. I mean, I, okay, he's going to discuss the double slit, so just ignore. You can just hear the names, because de broil. This is pronounced de broil. It's actually French. So I like my theory. I use actually I use de broil all the time. I because I convert particles into waves and waves into particles, and that is de Broglie's discovery. Matter is both a particle and a wave, and he just said matter is both particle and a wave. Do you understand? Do you understand this statement?
Well, I know how a wave and a particle are supposed to act.
Wait, what?
You're asking me if I understand the statement that matter is both a particle and a wave.
Yeah. Do you understand it?
I'm responding. I know how a particle and wave are supposed to act.
But can you say that something can be both a particle and a wave?
Seems counterintuitive.
Exactly. And is counterintuition a legitimate scientific explanation?
No.
Exactly. I would say it's a non explanation, therefore, it is unscientific. It's an unscientific
But
statement. Hmm.
many scientific views are contrary to intuition, anyways.
Wait,
So,
what?
many scientific postulates are contrary to intuition, anyways.
That's exactly what Proposition 90 says is not true. Proposition
Is
90 says exactly the inverse of that. Proper science is first of all understandable. If what you're saying is scientific and is you claiming it's not understandable, congratulations, it's not scientific. You cannot say I have a scientific idea that is not understandable. That's not science.
I'm I'm not saying it's there's stuff in science which is not understandable. Like something can be counterintuitive yet still understandable. I'm just saying,
Oh, that's
based
fine.
on how we seem to think, sometimes science goes against it, and we're like, "Oh, is that actually the case?" But there is an explanation grounded in science. It's just contrary to what we would have thought.
Exactly. But if the explanation is that matter is both a particle and a wave, that's the explanation. That's the theory. Can you accept it as a scientific theory? The green. Can you accept the green as a scientific theory?
Um, it seems like a tough pill to swallow. Uh,
Would you
I
accept
mean,
it?
you can, but you can, but it's not very satisfying.
Look, it's up to you. You define your science, I'll define my science. Everybody defines their science. My science is if it's not mechanically understandable to a child, if I cannot build a contraption out of it, then it's nonsense. It's not science. So,
Well, me, yeah, I don't see what the issue is, but what do I know?
right, you still don't have a good feel for what science is to you. You haven't done any independent work, I think, because I just introduced you to science basically 2 or 3 days ago, right?
Yeah, not yet, but eventually when I read the literature, I'm like reworking my mathematics right now. So one day very, I'll be a better like judge of and critic of all of this and stuff like that.
Fantastic. So, in the beginning, it's okay to be open minded and to just listen to what everybody says. But this, for me, the broil, it didn't blow my mind. I just hated it. Until this morning, I hated the broil. And now I love him. I love him more than anyone else because he shows up in my theory. I need him for my theory. He completes my theory. He allows for the particle to convert into a wave in order to travel through space fabric to the general relativity space fabric. And then when the wave completes the traversal, the propagation reaches the target, interacts with the target, with the detector, the wave can turn back into a particle and be experienced as a particle, again using de Broglie, because de Broglie allows, he has the equation to just convert matter into wave and wave into matter. And so until today, I hated him. Even though Einstein approved his PhD. This is his PhD. De Broglie's PhD is just this. He said, "All right, all particles are also waves." It's like because I said so. He predicted the experiment, the double slit experiment with the electron. He predicted that you're gonna get wave formation for the double slit experiment with the electron. Can you believe it?
Can you repeat that?
De Broglie predicted that when you
Okay.
run the double slit experiment on an electron beam, you're going to get an interference pattern. Even though
Oh,
electrons,
okay. Oh, wow. And did he do this before the experiment took place as well?
yes, he predicted it,
Oh, wow.
they did the
Okay.
experiment, and they got it right. And
Damn.
that was his PhD. Unbelievable. This is like I have my, like I feel so strongly about my intuition of my explanation, and I understand how these guys felt. Like when he wrote his paper, he knew it in his bones. He felt it. I don't know how. It's like sometimes people just they feel it and they say it's got to be it. And Einstein said, "Yep, he's right." Einstein was also brilliant that he was able to say, yeah, and they tested it and it worked. Einstein was like the most intuitive of everyone of everyone. He was just so intuitive. Like he made so many predictions. Like it's unbelievable. It's like his predictions are off the charts. It's like he went on zero information and just made the predictions about the universe. Unbelievable. Just mind blowing. Anyway, let's continue. So once they did it for electron, the prediction of de Broglie was it's going to work for everything. He said, actually,
Mm.
any particle, any beam of particles, you might as well throw water particles. You might as well throw cats and dogs and planets. They're also going to disperse or distribute themselves in a pattern that looks like a wave got through. It's just that the bigger the particle, the less it's going to show up. The smaller the particle, the more it's going to look like a wave. So with photons are the smallest. So light shows up perfectly like a wave. Electrons are the next in line. It's going to show like almost perfectly like a wave. And the heavier you go, it's going to look less and less like a wave and more like particles. It's just because of the mass of the objects, as far as I understand. But this was predicted by de Broglie. They only tested it on electrons, but they might as well have tested it on complete atoms and stuff. So do you?
Can you go back 10 seconds?
Yeah, this is the most important thing, and this animation is really amazing Because this really makes zero sense. Because an electron is a single particle. How could it do that? How could it go as a wave through both slits? What's going on?
Mm.
What do you think?
Uh, I don't know what commentary to give, but other than it's interesting.
Yeah, but how do you explain a single electron going, which is a particle, suddenly going two slits as a wave? What's your explanation? How could that be? And then it reaches the detector and bumps up as a single particle. Like in a particle accelerator, we see electrons, but when they travel through slits, they become waves. How do you explain that?
Uh,
So scientists, including Einstein, throughout his entire life, couldn't figure it out. No one until this morning has been able to figure it out.
let's see.
Yeah, let's continue.
I'm interested in an explanation.
Excellent. Actually, I already gave you the explanation, but it hasn't hit home for you because you didn't understand the question. So you need to really, really, really understand the question before you start to understand the answer. Let's continue.
Interesting.
So a neutron is by far heavier than an electron. It's much, much bigger. A neutron is composed of three or six particles. It's huge. It's like a city compared to an electron. So if a neutron also behaves, also does this, then this is just unbelievable. If this is true, I'm assuming I never conducted these experiments. Neutrons, by the way, are very dangerous because they cause cancer because a neutron is neutral. So it could bump up against your DNA and smash it up and create a cancerous DNA, and they do.
Um,
So you got to be very careful when you're near neutrons. They go through walls, they go through everything because they're neutral and everything around us is protected by the electron field, but a neutron does not interact with an electron. It just goes right through an electron cloud. It goes right through molecules and atoms. So that's basically radiation. Very dangerous. Neutrons are, I
oh
would
yeah,
say,
no.
yeah, neutrons are very dangerous.
So much for a fine-tuned universe.
Wait, what?
Yeah, I was gonna say so much for a fine-tuned universe.
Basically, yeah. I don't know how he's doing this calculation, but I mean, fine. That's like really tiny. So obviously, look, I will come to my theory because according to my theory, when I move my hand, it actually becomes a wave. So we'll have to think about that.
Oh well.
Okay, I don't know what else he's gonna say. This is like boring stuff. Let's look at the picture. He's gonna cover the picture, a famous picture. Oh, the wave function, that's really easy actually. Sorry. Can you tell where Einstein is in this picture?
Yeah,
You see him?
yeah. He's the
Okay.
first person I saw.
Do you recognize anyone else?
Uh,
Do you see? Are these all men or is there one nun?
oh, the guy on the right, second to the right. I recognize his face. I don't know who he
I
is.
know. Yeah. I don't know. It's one of them. But do you see any women here?
No,
Look, you'll find. You'll find. There's one woman here.
what?
There's a chick.
Where's the
You see her?
where is where is where is the female?
Where is she? She's
The Floyd.
so you see Einstein, one to the left. I don't know what that is. Probably I don't know. But Einstein is at the center, so he's like the most important. But two to the left of Einstein. Do you see a chick?
Oh yeah, I do. Yeah. Okay.
Do you know her name? You know who that is?
No.
I think it's Marie Curie. She actually discovered radiation. And I think she died of radiation. Her husband died of radiation. And she actually got two Nobel Prizes. She was tough. She's a tough woman. Anyway, okay, let's continue. I don't know any of the names. I do recognize very few of the faces. This
Are
is,
these guys like all in the same time period, or is it like?
yeah, they actually
Oh,
met.
okay.
In those days, these people met. This is one of the last times all the great physicists met together. Because, like, later there would be just too many, I think.
The Alan Turing.
Wait, who?
Alan Turing. No, I don't think
Turing,
it is. I don't know.
Turing is World War II. These guys, this is probably around. This is way before World War One. This is probably I don't know, like 1915 is still before World War One. That's when Einstein figured out general relativity. I think this is before. I would say this is like 1910. So here's Schrodinger. So Schrodinger, he created a very nice formula to describe the wave equation, the shape of the wave that we just saw. That's what he's famous for. Just a mathematical description of the wave equation. That's all. And everyone is so perplexed about his equation. But I think around a year ago, I figured it out, and it became so simple. I'll explain it to you. It's going to be so simple. You're going to laugh.
Okay.
Yeah, the Schrodinger. Yeah, Heisenberg. Okay. Yeah, okay, that's good. So we just wanted to see double slit experiments explained. What I wanted to show you is that no one has an explanation. So this is Brian Greene. He's professor of theoretical physics at Columbia. He's chair. He's like really famous. You know, everybody knows Brian Greene. He's like a celeb. Sorry, my internet is too fast for the universe.
Let me see the guy. I think was it Brian Green.
Wait, we're watching. We're gonna watch Brian Green. It's okay. We're gonna watch it. Do you want to watch it?
Yeah, yeah, okay. Yeah. I'm just saying I know this guy.
Oh, you know this guy?
Uh-huh.
Okay. Too bad he's not actually showing the actual experiment and then doing the analogy. I hated that they start with an analogy and never show the experiment.
It's still how break it down.
Fine. But he didn't show that. Did you understand that he was throwing it through the two slits? Did you get it?
Yeah,
Oh,
yeah.
okay. Oh, so I was wrong because I told you between the two slits you're not gonna see anything. So yeah, between the two slits, he says that you do get a constructive interference pattern. It's actually nice that now they're showing a bunch of celebrity physicists, and each one is really expressing the paradox, so that you know that it's the scientific consensus that it's a paradox. It's an unresolved paradox.
Hmm.
That's nonsense. But when I'll explain to you Schrodinger's equation and I'll show you actual mechanical animations, you'll understand it. It's so simple. They're confusing it as usual for no reason. They're just giving unscientific explanations for no reason. Do you understand what he just said?
Which part?
You what? You missed?
No, I watched it, but it didn't seem like he was really saying anything.
Exactly, exactly. Now they switched into
Oh
nonsensical.
wait, what? Really? Okay. No, I'm just surprised you agree. I didn't think like it.
Of course, I agree. I mean, I came up with my theory because they are full of nonsense. I've for years
Okay.
trying to understand them, and I gave up on their explanation piece by piece. It's not like this morning I figured out everything. It's for years I've been piecing the puzzle pieces together differently than they have. But it wasn't that complete. It didn't become complete until this morning. It finally, all the pieces came together perfectly. But each one of the pieces, for years, I've already been working on my separate sub theory. Like I have my own explanation of Schrodinger's equation, and I think my explanation is not nonsensical. It's very mechanical. But I'll show you later. That's correct, but it's not a probability. I wouldn't say it's a probability wave. That's like a confusing way to phrase it. I wouldn't call it a probability wave. The shape of the wave, forget it. It's confusing for no reason. Schrodinger just wrote an equation to describe the very distribution that we saw on the screen. We saw a distribution on the screen, and he related um, a bunch of stuff in order to just make a prediction about the the shape that is going to show up on the screen. That's all he did. He just made it, and then he said, okay, but remember, every time you're going to get one electron to land somewhere on the screen, that altogether it's going to look like a wave distribution. But every time you're going to get one electron to land somewhere. So I'm going to give you the probability of each electron hitting anywhere in the detector. Anyway, I'll show. I don't want to like confuse you with like too many words. So for now, I would, if you understand what they're saying, fine. If you don't understand, it's also fine. That's utter nonsense. Those words are you cannot make statements in science that are nonsensical. So they're being unscientific. I don't know why they're doing it, but they're being unscientific. Either they don't understand, I don't know. I have to assume they're just confused. They don't understand. I don't know what's going on. But for me, it's much simpler. That's nonsense. You're not allowed to ask whether you're allowed to ask. You're going to get a probability for an answer. Of course, you're going to get a probability for an answer. It's like if I flip a coin, I'm not. You're not going to know how it's going to land, but you know the probability. Let's say it's 50-50. With a dice, it's 1 out of 6. With a bunch of cards, it's 1 out of 50, and stuff like that. You're allowed to ask, and you know the answer probabilistically. There's nothing wrong with that. The fact that he's saying you're not allowed to ask, no. Are you following at all, or am I completely putting you to sleep?
No. I understand. Like, there's no use in muddying the waters with gobbledygook.
You call this muddying the water? When somebody says gobbledygook, you call it muddying the water?
If there's a simpler explanation and you're giving a extremely complicated explanation or saying something trivial, then yeah, you're muddying the waters.
But my belief is they are as lost as you. They just get paid more.
But they are making a money off of saying gobbledygook then if they aren't saying
Yeah,
anything of value.
yeah.
So they are muddying the
I don't
waters.
want to blame them for being hip what do you call it, like a hoax. I don't want to say that they are a hoax.
Quacks.
I
Quack.
don't want to. I don't want to say that. It wouldn't be fair because they think they're doing their best. And what,
No, no,
what,
they don't.
look, they're pooping their pants trying to figure this out because the first guy to figure it out is going to win a lot of respect from the others. So they're all trying to figure it out. But for some reason, I think because they're all like in a sort of a cult, that none of them is thinking out of the box. It's like for me, it's easy to think out of the box because I'm not part of the cult. I'm not part of the club. So for me, I'm always thinking, okay, Einstein was a dummy dum dum and he didn't understand. Like I'm open minded to say, okay, he didn't know this, he didn't know that. Everybody knows he didn't know. Everybody knows Einstein went bonkers for his last 30 years about everything. He went like he stayed at home, didn't talk to anyone, just wrote notes, and got nowhere and died. And he was so upset about quantum mechanics that it just drove him basically, I wouldn't say to insanity, but he couldn't figure it out. And today the scientists are as baffled as he was all this time. It's just that they're saying shut up and calculate. That's their thing. They're saying, look, Einstein didn't understand, we don't understand, but at least we understand that we have equations to predict what an electron is going to do. We don't know why these equations work, but the fact is they work. The experiments prove that our equations work. The equations are not built on a mechanical theory. They're built on gobbledygook and it works. What do you want from us? We're telling you, at least look, at least they're transparent. At least they're not lying. At least they're transparent. They're telling you we don't know. And they have all different types of theories, but these are not mechanical theories. These are incomplete theories. But they're trying. At least they're trying. And I would say, there's almost no consensus on quantum mechanics on the explanation. It's like there's so many schools of thought about what is the interpretation, like what they're saying about the probability and stuff. That's like one school of thought that's called the Copenhagen interpretation. Like you speak to different physicists, they'll give you different answers. There was actually a
Hmm.
survey, and different physicists gave completely different answers. There was no consensus. Like they got as many answers as they asked physicists, or something like that. Like so many answers, completely different theories. So they're all confused, but it's what, fine, whatever. You see, when you see something like this, where they show you mathematical symbols on
Hmm.
digital waves, so they're trying to tell you this is like magic. This is the modern magic. This is like in the old days, the priests would read from the text of the Bible that no one could read because no one knew the alphabet. So whatever the priest said, everyone believed it was the word of God, and it was from God and from the King and from from Jesus, and you had to believe them. You had no other. You couldn't cross-reference anything. You couldn't cross-examine anything. You had nothing. You were busy from dawn to dusk. You were busy feeding yourself, and you basically always starving. So that was life. But this is
That's
like
how life is. Yeah.
what?
Yeah, I'm agreeing. Like you're saying a lot of truthful stuff. Like I'm just nodding my head in agreement.
Right. But today we don't have the priesthood. We have the academia. We have the scientific elites. And they're doing the same thing. Like, this is terrible. This is terrible. Just say we don't know. Don't show us mathematical symbols on digital waves of like don't do this. Don't confuse us. If you don't know, just say, I don't know. We don't know. Show a clown dancing and tell us it might as well be a clown dancing, and that would give us a better explanation of what I could. Say that. Don't do that. Don't try to impress us with your advanced math and stuff. Don't do it. This is like pretending there is a God, like pretending that you're a prophet, pretending that you have the word of God. This is pretend. This is lying. This is very bad. Because then the public,
Sophistry.
what?
Sophistry, yeah.
Because then the public thinks, oh, they know, they have the answer. Oh, these are people. Oh my, because you might get the impression that they know, but they don't. They just told you we don't know. We're so baffled. We're confused. Einstein didn't know. So you know, nothing happened since Einstein. Nothing. That is such nonsense. That is such nonsense. Absolute nonsense. It doesn't make any sense. You're allowed to ask this. You're allowed to ask whatever
Yeah.
you want. What is this nonsense? You get a
Yeah.
probability. You get a probability of the distribution. It's a probability of distribution. That is all the Schrodinger's equation is. The wave is a wave. It just looks like a wave. It's a wave of probability, but it doesn't just look like a wave. It ends up looking like a wave because the probability distribution looks like a wave. If the probability distribution where the particle is going to be looks like a wave, then of course it's going to look. The end result is going to look like a wave. It's just that each time the particle is located as a wave, as a wave predicts the height, the value of the probability is a wave. It's not a wave. It Forget it. I'll show you later. It's so simple. It's ridiculous. And either they don't understand it. I have to assume these guys just don't like it. It is what it is. They just don't understand it. I don't know. I don't know how you can not understand something so simple that I figured out such a long time ago. Terrible. I'm going to show you later. You'll understand. I think you'll understand it very quickly. Let's continue. It's not. How can you say it's right? All he says is that his math comes out right in a particle detector or in any experiment that he conducts. That's all. He doesn't have a scientific theory. He doesn't know why it works. He doesn't have a mechanical, right? You see this is his mechanical um, model of reality. This is his mechanical model. Yeah? His mechanical model has the Greek letter psi or whatever, or H, or nine, or H squared, whatever. That's his simple mechanical model of reality. And this ends up coming out right. That is so nonsensical. This is not science. But that's true for anything. If you fire a gun, if you throw a ball, you cannot predict exactly where it's going to hit. You're never going to get it exact. You're going to, okay, even if you see where it's headed, because of air, because of this, because you're always going to miss. You're not going to be infinitely accurate. I don't care. You're never going to be infinitely accurate because you never have all the information about the ball, about the air, about the humidity, about every molecule of air. You don't have all the information. So, of course, something minuscule is going to happen to the ball or to the bullet along the way, and you're going to get it just a little bit off. You can fire from the most perfect rifle 2 shots. They're not going to land the same place if it's far enough. So what? So that's it. So this probability, we have this probability in life. Why are they making such a big deal out of it in quantum mechanics? I don't understand. This is so ridiculous. And they're showing you again with they're showing mathematical equations, and of course they're not going to explain it. They're just going to show you beautiful long mathematical equations without an explanation. Go kill yourself. This is, by the way, Schrodinger's equation, and it's very simple. It doesn't say much. It says very little. It just says, basically, I don't want to get into it, but basically it says this is why it ends up looking like a wave pattern. This ends up looking like a wave pattern. That's all it says. That's what it has to say. If Schrodinger's equation is supposed to predict the double slit experiment with electrons, then that's what it has to say. It has if you're telling me it's correct, I don't need to know math. I don't need to know Greek. I don't need to know anything. If you're telling me the Schrodinger wave equation defines or describes something about the electron that ends up, that we know what the experiment looks like, and you're telling me you have a mathematical equation to predict it or to describe it, then this mathematical equation describes it. I don't need to know math. It's a simple wave equation. I told you before about wave mechanics. It's the same equation for wave mechanics. That's all it is. It's just wave distribution. With he played around with the constants. These are called constants in order to fit the data. He just made this. It's not a theory. This is not a theory. A theory is a mechanical model. There is no theory. What I'm telling you now, that's a theory. The way I'm explaining the equation, Schrodinger's wave equation, that's a theory. I'm telling you, okay, how did he arrive? By the way, they never teach how to derive this equation. Einstein said, I don't know how he derived this equation. Einstein said, I read Einstein. Einstein didn't know how he derived. I don't think he ever showed anyone how he derived it. I don't think he he knows how he does. I think he just pulled it out of thin air because I mean, it's just a wave equation. This is how all wave mechanics look like this exactly, always and forever. That's all it is. And I don't understand why Einstein couldn't figure it out. And I don't understand why they don't teach how to. I don't know. I mean, if you look up where did Schrodinger get his equation, I don't think that anyone teaches that he arrived at it somehow. Besides that, like he just guessed it or something. Let's see. How did Schrodinger get or derive his wave equation? Let's see if I can get this. Schrodinger's wave equation was derived by Erwin Schrödinger in 1926, building upon the work of Louis de Broglie, who proposed that particles such as electrons exhibit wave-like behavior. Schrödinger aimed to develop a mathematical framework to describe the behavior of these particles. Postulate of de Broglie. I don't know. I don't know what I'm missing. This is too simple. I don't understand. I don't know why it looks so complicated. Okay, let me just put the link. Copy link. Maybe I'm missing something. I don't know. As far as I know, it's really simple. Let me just go all the way down. What's going on? Why is there so much? Who is this saying yo-yos? In 1999 and subsequent DCQEs are by far more interesting experiments, in my opinion. I don't know what he's saying. Here you go. This is. Oh, this shouldn't be in general. This should be part of the YouTube video. So let's put it in YouTube video. So this is the Schrödinger. All right, let's continues. We need to go to General. We're gonna watch this. Okay. But why isn't he explaining? If you're going to show an equation, the least you can do is explain it. I'm not saying derive it. I would say derive it from first principles. It shouldn't be difficult, but at least explain it. The least you can do is explain it. And by the way, this function c, that's just the function of where and when the particle is. That's it. So at the end of the day, you want to find out what this function is. So you want to be able to plug in where the xyz, x stands for xyz, and t is the time. So you want to be able to say when and where, and this function will tell you the probability. What is the probability that you're going to find it there? That's all it says.
Okay.
It's really elegant, and what comes out of this is really incredible because this equation predicts what atoms look like, which is totally unbelievable. From
Oh wow.
you predict what the atomic cloud looks like, what the electron cloud. You get all the electron clouds from this thing. This is just unbelievable from this relatively simple equation. I don't know exactly how you do it, but it's doable. I didn't get that deep. Anyway, let's continue. When he says probability wave, that's so terrible. Like, don't say that. Just say probability. Don't say probability wave. It ends up being. It looks like a wave, right? Because the probability is a wave. It's confusing. Even when I say it, it comes out confusing. My God. Good. Oh, it didn't end. I clicked it. It's the next video. It doesn't matter. But he didn't say we don't understand the double slit experiment, which is all I want him to say. Just tell us we don't understand the double slit experiment. Okay, boy, was I wrong. Who is this? Oh, Arvin Ash. Delayed choice. I don't care about delayed choice. She's not doing quantum. Is that a wave or a particle? Let's the double slit. Let's hear Don Lincoln. Let's see what he says. So far, do you understand what he's talking about?
Yeah.
Okay. The animation here is absolutely horrible. I mean, none of
Yeah.
the
Yeah.
animations,
After.
yeah, complete make no sense. I mean, it's like the I don't know who did the animations. Like they paid them $1.50. Here, make some animation that make no sense. It's really they might as well don't. They might as well not make animation if the animations are going to be incorrect. Like all these animations until now, including the water, even the water, there was no, I didn't see two slits in the water. I don't know what he's talking about. He just showed water. He just showed water waves.
Yeah, but it was very unclear.
Yeah. I don't know what he's talking about. I don't know.
Wait.
So the other experiment was actually what Einstein got the Nobel Prize for, also published in 1905 in the Miracle Year. That's one of the three papers. So the photoelectric effect, that you shine light on metal and basically electricity flows. Maybe I should show you that experiment maybe later, but for now, you can assume that light sometimes behave like a particle. Light is composed of photons. Einstein proved it. I never believed it until today. Like I always doubted it, but today I know that it's fine. It's probably true. It fits it because everything is both a particle and a wave, as far as I'm concerned. Today I know it to be true. So what are we seeing in this frame? Can you explain to me this frame? There's it
Top or bottom?
both. The top is X, the bottom is check. Why is the top X, the bottom check?
Well, because that's not the X. It's X because that's not how light acts when it travels through the two slits. And
Fantastic.
when the bottom one, that this is how it acts when it travels through the slits. It acts like a wave. It
Fantastic.
the the molecules which make up the light, they like overlap and they just act like a wave. I don't know how to say it without drawing it, but they're smashing into each other and they are forming striped like a striped formation on the ball.
Good. We're getting bands from interference. From constructive interference, we're getting the dots, the bands, and from the destructive interference, we're getting the black regions. Yeah, perfect. Perfect explanation. Perfect explanation. Good. So I never thought about this. This is interesting. If this fits my theory, let's see. Right, because they didn't know what's going on. So they said, when exactly is this particle becoming a wave? I mean, we sent away a particle. It reaches the detector at the end, the plate, the board, the display. It reaches as a particle, but in the middle, it must have turned into a wave. But it's a single particle. So, is the particle going through the left, through the right, through both? What's going on with the particle? So they put a detector. Let's see. So what he says: two slits with detectors. So he says when they tried putting I don't know what a detector is. The terrible part of all these videos, you don't see the actual apparatus. So he says detector. I don't know what a detector is. I don't know. Do you want to see the description of the thing with the detectors? Is that important to you, or do you want to move on? Because
Yeah, I want to understand what the detector is.
but he's not going to tell you what a detector is. They never show the apparatus. That's what I was telling you. They never show the actual experiment setup. So you're never going to know what it is. I to this day have never seen a detector in my life. I've never seen a
Oh,
detector
okay.
in my life. I know all these videos by heart. I've never seen a detector, and I've searched. I've searched YouTube for the actual setup. Please show me the setup. There is no setup. No one shows the setup. I know it's like you cannot believe it. That's the fact. So, but we can watch it if you want. Let's try. By the way, I don't know if he's ever seen a detector. I don't know if he knows what a detector is. That's one of the problem with these scientific elites. And he's supposed to be an experimentalist. He works at Fermilab. Fermilab is a Department of Energy like laboratory. He's supposed to run experiments, like high energy experiments. But I don't know if he knows what the setup for this experiment is. I just don't know. And he's one of the better ones. He's like the least of an elite of all of them. He's like the most down to earth. I hate him the least. I actually kind of like him.
Can I send a video I watched before from
Yeah,
it talks about like the double slit experiment, but it was from a documentary made by scientists in the field.
we could watch it
I
after.
want
Well,
I want
you want to watch it
I
now?
wanted to hear your no, you we'll do this, but I just wanted to hear your review of what you
Okay,
were saying.
that's fine. Notice that he doesn't say that Deepak Chopra is wrong because he might be right because they still don't have the answer.
Oh, I thought this guy Deepak Chopra was like some sort of guy who had it all wrong.
Yeah, but you have to prove, or you have right.
Yeah, I know. That's just like the consensus that people like laugh at him and stuff like that. I don't
That's
know whether it's true or not.
right. That's a little dangerous. Like you need to be able to disprove him without laughing. Yeah, like I don't think he is. Like I don't think he feels he's wrong. I think he feels. I think he feels like Mandible. Like I think Mandible feels correct. I don't think Mandible feels like you saw how Mandible wouldn't leave us. Like he was so upset that we criticized him. So these people, I think he reminds me of Mandibles. Like these people really believe what they say.
I don't know who Mandible is, but okay, go ahead.
We debated him about
I don't remember him.
3 days, like 4 days ago. Mandibles, Mandenden,
I don't remember. Let's go.
Mandenden. We debated him for 3 hours, and I said after that my life got upheavaled. My theory of
I
science, like we debated
don't remember. I don't know
freedom of
who this guy you're
freedom
talking
of choice. We debated freedom of choice. He said there is freedom of choice because there is in the quantum indeterminacy. Anyway, it doesn't matter. Yeah, but how do you know that really one photon is emitted at a time? You can't see it. You can't see one photon. I don't think so. So how do you know? So it depends on a mathematical calculation. You're assuming, you're like trusting Einstein. That's fine, but I mean, this guy Lincoln probably can derive the equation, so maybe he knows. Maybe he feels that it's correct. I have no idea. And there's no video of it. Too bad. Notice the animation doesn't show the interference pattern becoming lighter and lighter. From the beginning to the end, it looks the same. So whoever did the animation, my God, are you understanding what he's saying right now? If,
Yeah, but this video is a lot very inferior to the other ones you was showing.
right, but Don Lincoln, I like him. I feel like he's a good explainer, and he's an experimentalist. I always prefer experimentalists over pure theoreticians. But do you want to stop here and move to the other video?
Uh, no, I better not to watch the video anymore.
You want to you,
We'll
you want to
carry on this.
you want to finish for tonight?
Yeah, I guess so. Yeah, being quite a lot to take in, I guess.
Yeah, for sure. I mean, yeah, I really appreciate your ability to sit and study for 2.5 hours. This is really intense.
Yeah,
Like,
I'm just very interested in learning and building knowledge. So yeah, I'm never gonna shy away from that sort of experience.
that's fantastic because I'm really enjoying going over all the material and doing like a complete presentation, and I want you to really feel the 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 that the problem has never been solved, and to really feel like you don't have a solution, and then try to use my solution and see if you feel like it gives you it puts your mind at ease that okay, that's a good explanation and everything is much
Mhm.
better now. Anyway, okay, so text me tomorrow when you're ready to
Mhm.
go, and whenever you want we'll continue.
Of course.
All right, man.
Goodbye.
Goodbye, good night, bye.
Take it easy.
You too,
Yeah.
bye. All right. All right. Okay, everyone. Let's read some comments. This guy, real Cygnus. So I don't know what these comments will love. So far, the more interesting experiment, in my opinion, you really only need the data though because it's intrinsically so statistical. No, I need to be able to reproduce the experiment. You should never trust anyone over anything. They've all been reproduced. Science isn't a YouTube video, bro. Yeah, but I need to reproduce. The fact that you're telling me that it's been reproduced, that's nice, but I want to reproduce these experiments. At least I want to know. I want to see someone who reproduced it. You're telling me it's been reproduced. I want to see them reproduced. And I want the explanation of how they were reproduced. And I want the explanation how I can reproduce them. So you saw that he presented a paper. The paper explains to undergrads using undergrad equipment in the lab how to reproduce these experiments. So it's not so straightforward. I would not know how to begin. Even though Young did it 1,000 years ago, I wouldn't know how to begin. Like all I know is rumors of how these experiments were conducted. I don't know how they were conducted. All I see is animations. Real Cygnus says actually field to the best current understanding, not a tiny ball. What do we have here, flat earthers? For Pete's sake. Okay, but that's what you say. What do you mean? I I'm looking for an explanation of the double slit experiment. You saw all the experts. They were talking about balls. So I'm not the only one talking about balls. They weren't saying, right? When at the end you see a dot on the screen. You don't see like what you say field. You don't see a field. You see a dot. So you have to at least end with a dot. And I would say you want to start with a dot. You want to look. You can do whatever you want. You just gotta give me a mechanical explanation. I don't know what a field is, so I don't know. I just don't know. Like, whatever. Tell me. Like you could have joined us. You could have actually said something, but you chose not to. I don't know why. And Woody Johnson says, "What's up, slave? What's up, Woody Johnston? All right, everyone. I'll see you next time. Bye bye."